Hello everybody. What are we gonna build? This! When are we gonna build it? Slowly over the course of the last year. Because I hadn't decided if I wanted to be internet famous yet. So I filmed some of it, I didn't film other parts. It's all getting cobbled together now. A while ago, I got this for the kids to play with, and they spent many hours playing with it. So naturally, the logical next step was to spend 100 hours building something way more complicated that they would enjoy like 20% more than the thing that cost $10 on Amazon. Because engineering! Please excuse the general lack of continuity. We're now 15 hours into this print, not that my camera can pick up this screen at all for some reason. But, it's coming along. I kind of hate doing giant prints like this because they're nerve-wracking. You never know when they're going to explode. And you can spend an entire day and get nothing out of it. It's the best. Sidebar, one of the things I like about 3D printing is all the things that you 3D print to help you 3D print. Like I 3D printed this box to put my 3D printing scraps in. And I 3D printed this little thing so that I can scrape off my pliers on it if something gets stuck to my pliers. It's critical stuff. We're at 23 out of 35 hours and still going strong. So far, so good. The kids would probably have fun just playing with this thing all by itself, but for some reason that's not good enough for me, so my plan is to make this thing control this thing. So there's actual propellers that spin around and stuff. And I have this set up with a network jack, so I can just use Ethernet cables to connect everything. And then I can make it as long as I want and don't have to do any more soldering. Hooray! I made this thing all spiky on the bottom, so hopefully it'll just stay put wherever they put it, and it won't just vibrate itself right off the couch. There's a slight risk of blood loss. They're a little pokey. We'll see how it goes. It'll be fun. Here's my box for prototyping all the electronics. Why am I building them in this box instead of on my desk? Well, obviously, because this box was already full of stuff from a different project. And this box has another project in it. And, well, the desk is just always like that. Now that I got all the wires attached, all I have to do is hook it all up and find out what I screwed up first. 'Cause there's gonna be something. There's always something. Alright, it's time for round one of what could possibly go wrong. Electronics edition. I got everything wired up. Hopefully correctly. Minus the actual microcontroller. This is just to test all the dumb circuits. All the lights and switches and stuff. And I made a diagram, so there's basically no way that I could have done any of this wrong. Let's flip it over and see what happens. Alright, here goes. We'll either see lights or smoke. Or nothing. The answer is nothing! Off to a good start. Alright, I figured out what the problem is. It's kind of dumb. This USB power bank requires a certain current draw before it will automatically trigger on. So I have to push the button to make it turn on because there's not enough current yet. 3, 2, 1. Amazing! Things. Stuff. Oh, look at that. I very clearly wired that to the wrong one. Yep, these are reversed. Beautiful, beautiful. Let's see if these work. Oh, look at that. Beautiful. Yep, that's how they're supposed to work. I'll explain why they light up weird later. I feel like these propellers turned out pretty good. I did extensive research to recreate a Lockheed design from 1946, and you can really tell. Just kidding, I just eyeballed it. I thought it looked cool. The proportions were probably all wrong. I really future-proofed this design by designing the entire thing around this random bag of screws that I got with something else I bought. If I ever want to make more of these, I'm either going to have to figure out what size these screws are, or redesign the prop to fit a screw that I actually know what it is. Brilliant! I wanted the engines to sound like real airplane engines, so I came up with a way to mount these vibration motors. So they're basically just suspended in here in a little thing that can bounce up and down. And it makes a lot of noise. While I succeeded in making it sound like an airplane engine, I also failed in making it sound like an airplane engine, because it then occurred to me that airplanes are very loud, and my kids are going to play with this inside my house for hours and hours and hours. I'll find something else to use them for. Outside. I got the speed and the acceleration rate of this motor just perfect. And then when I went to actually put the cover on, I discovered that it has the world's crappiest soldering job on the cables. Thanks, China. There's probably a correct way to protect a circuit board when you install it in a final product, but my solution is to just print a little tray for it and throw it in that. And theoretically, then if any wires pop loose, it's not going to short anything out. At least not in a way that's going to make a lot of work for me. I was going to try and mount all of these boards to the back of the cover, make it look really nice. But as soon as I tried to actually position everything on there, I realized that's just not going to happen. And it's never going to look nice. So I'm just going to let everything flop around in the box, and we'll see what happens. It's finally done. Time to see what the kids think of it.
Wait, can I try it?
Should I show you how it works?
We're trying to figure it out.
I think you're missing one important thing. It's sitting right in front of Jake.
Here, we should blast off.
Oh, the box is so cool. This is amazing.
Oh no! Come on, arm quickly! Shoot the missile! You need this. You need this wheel to aim where the missile goes. Okay? A little bit that way. Uh-huh.
What do you guys think?
I love this. Yeah, we each have jobs.
Perfect.
Shoot the missile!
In case anyone's curious what's in here, here's the inside, courtesy of the Brio Railroad kickstand. After putting this all together, I suddenly have a newfound respect for, like, aircraft engineers that are wiring up panels of, like, dozens of switches. Because there's only, like, 9 or 10 switches on this thing, and a couple LEDs, and some motors. And this is the giant rat's nest of wires that results from that very small panel. I can only imagine what the wiring harness for something with like 100 switches on it would look like. The brains of this thing is an Arduino MEGA board. Technically, it's a cheap Chinese knockoff clone of a mini version of it. That's what's reading all of the inputs and setting the outputs, turning some lights on and off, controlling the speeds of all the motors. Some more highly professional stuff here. Gobs of hot glue to make sure those wires don't come off of the key switch. A bajillion of these little screw terminals for all the wires. And LEDs on this. I'm using 4 of these motor drivers. The model number will now magically appear on screen because I can't be bothered to make a script and look it up ahead of time. There's 2 in this box, just flopping around as previously stated. But you can see this sweet 3D printed little circuit board guard around it. So nothing can possibly go wrong there. There's 2 motor controllers in this box, and then there's 1 in each engine set. The rug that really ties the room together here is this solderable breadboard. These are great because the layout is the same as the breadboard that I'm building all this stuff in before it gets put together, so it's really easy to just move things over. Some people like to design their own custom PCBs. Good for them. I don't have the time or the patience for that. This works just fine for me. A nifty little trick I like to use for powering these Arduino projects. If I have a stable 5-volt power in the project somewhere, I just run it straight to the 5-volt pin on the Arduino. The only problem with that is then if you want to plug in your USB cable, you have to disconnect the 5 volts power going to it. Otherwise, you're hooking up your power supply to your USB port. And that can cause problems. So I had this little switch here, so I can easily just flip that whenever I need to hook up a cable for programming. I like to include these resettable fuses for anything that has motors in it, because I've definitely had these cheap Chinese motors stall and smoke before, and I really don't need anything starting on fire. These fuses are great. They are PTC fuses, positive temperature coefficient. The hotter it gets, the less power is allowed to go through it. So if power goes over a certain amount, they start heating up, and they start cutting off power. But then, once they cool off again, then they work again. So if something does short, you can just fix the short, and you don't have to actually replace the fuse. They can wear out, which is why this one is just screwed into a terminal block with the wires that it's protecting. So if I need to, I can pull it out. This is also handy because then you can put in a different rating if you want to tune it more to the actual power being used. Options, right? Options are good. I could talk more about the programming on this. I could definitely go into like a full code review, but I don't know if anyone really cares about that. Wow, this just keeps going in and out of focus, doesn't it? I think this video is plenty long as it is. Leave a comment if you care about how this is actually programmed. I'll just say that the biggest challenge of programming for microcontrollers is just that you have to use a really small font to make it fit on the tiny controller. The whole thing is powered by one of these USB power banks. I picked this one because it has an auto-on feature, and also because it has dual outputs, which significantly increases the amount of current that you can run through some of these tiny wires. You can double everything up. The other reason I like to use these like actual production power banks for projects is because somebody else has already done all of the safety things to make sure it doesn't explode. So I don't have to do that then. Because you can buy like raw lithium cells and, charge controllers and all that stuff and try and wire that up. But I never feel like totally confident that that's not going to burn my house down. I have more confidence in this. Not total confidence, but definitely more confidence. That makes me feel a lot better about giving this to kids to play with. All right, here's a little demo of how this thing actually works and why it has so many freaking wires in it. Got your key, of course. Most important part of anything super cool and overcomplicated. I tell you what all the meters do first. This is supposed to be battery voltage. It's broken, and I don't care. This is total system amps in green. The red ones here are the voltage that's going to these 2 meters, which show the engine speed for engine set A and engine set B. So like, here's the A stuff, here's the B stuff, A stuff, B stuff. And then the green on these meters is the amps for each engine set. I could have put labels on these, but where's the fun in that? People might know what it does then. This is just for fun, it does nothing. And this is just a thermometer, because it looks cool. And I guess maybe it would tell me if the box was overheating if it got to like 90 degrees or something. As far as the controls go, obviously the key turns it on. Here's the, let's call it throttle for motor set A, motor set B. Missile armed switch, which spins up a motor slowly. Fire missiles. Gotta have that. Then this is power for set A, power for set B, the engine selectors, so you can set which ones you want to have on, and then the engine enable for A and B. And they all spin on one by one, because I painstakingly coded it, so they can't all start at the same time. Originally it was just drawing way too much power, but it'd probably be fine to let them all turn on at the same time now. But it's not nearly as cool. And then you just take off. The nice slow ramp. So you can see total, this thing will use a little under 2 amps. It'll spike over that when you fire a missile. I think that is good enough. And if you really want to, you can pick which engines you want to have on. And then you can spend hours turning things on and off. And that's how it works. Ta-da!